And we should also invite our special guest to the scene, so Iulia Macavei. So great overview, Djordje. I think you did a really good job in browsing through all the, and I think what's really important is also to mention our, extensive resources that we have available, and that goes from describing the instrument, from application, use cases, but also the entire service package that's really extensive, that really allows you to do a lot of troubleshooting yourself, based on the application notes, the method-specific application notes that Djordje mentioned. You have a really good tool to qualify and ensure that things are running as it should. If not, then you will be guided through how to solve, what to do, and if you don't if you're not able to immediately solve the question or the problem, then the service team are extremely responsive and have all the right tools to help you out extremely quickly. So yes, I should just give Iulia a bit more introduction because, to be fair, I thought that this is your opportunity now to ask questions, and you should really just ask any question. You have myself, you have Djordje available, but I thought, okay, maybe hearing Djordje and myself discussing would be a little bit, boring. Sorry, Djordje, mostly me. So I thought, I'll go into
no offense taken.
And grab whoever I could find, and I found Iulia, and she's really good, and she's using the instrument on a daily basis, so she would be a really nice addition to help us answer all your questions. So let's dive into it, and please just ask questions. There's no stupid questions in this forum. It could be anything related to, whatever, essentially. So first question: what is the expected variance of repeat injections isolated on the tip, eluted, detected, of the same or very similar replicate samples? So it's a tough one to answer, but Djordje, maybe give it a crack, and I can probably also add a few comments to that one.
So the question was, if you just have the lysid that we repeatedly just load on different tips. This analysis we have done, and this is also available in several application notes, but we have data showing like in the less than 10% variance on the protein level across the board, across all of the samples.
Yeah,
in some cases less than 5.
Yes. Yeah. So I think again, look into the Evosep literature. A few comments that will obviously affect these kind of experiments is both related to which method you use and also how you detect the features, the peptides, because as fast when you start to run faster, then the method, the mass spec method, needs to be able to keep up. Of course, you need to get sufficient data points across those features. So I think if you just have, like, trying to do a protein profiling experiment where you basically want to capture everything, right? So you try to only measure enough to get decent quantification of those specific features. So basically, you're compromising the quantification a little bit, the reproducibility a little bit, to get more. But if you zoom in and you sit on those features, and this is kind of really what you should do if you want to isolate, how reproducible we can capture, elude, and detect features from the Evosep Eno, then that's really the question, right? Just to kind of loop out all the other variables. And here we get into the very low single-digit CVs. Obviously, if we try to run 500 samples per day, and we want to get everything, then we start to see the CVs go up. So there's a lot of literature available. One of the notes I can point towards is the throughput note, where we kind of discuss the compromise between depth and speed. And here you can also see that as we go faster, obviously the CVs will go up. But to Djordje's point, I mean, Djordje talked about the Evosep and some of the advantages of the Evosep. And I think another consideration is that when you load your sample, obviously, if you have a very concentrated sample and you try to load a small volume, then all of a sudden the pipetting or the sampling error of an autosampler will start to affect how reproducible you can detect that sample or those features. And here, Djordje also pointed out the standardized loading protocol for the Evoseps. And what we do is that we load the sample in bigger volumes. And obviously, having a slightly more dilute sample in a larger volume, that will minimize the piping errors that you will typically have if you try to, for example, inject 1 or sub-microliter volumes on an autosampler. So a huge advantage in this case, and we also have some literature describing how small losses we see due to absorption when we do these kind of experiments. I don't know if any of you guys have anything to add to this, but just a few kind of considerations. I think it's a very tough experiment, very hard to isolate in this case, just the performance of the Evosep.
I would just add quickly, Nicolai, to your point, just to illustrate. So this is something that I have troubleshooted with customers several times when the complaint was that the reproducibility, that the CVs are really high. And in almost all of those cases, it turned out that the MS method was not optimized. And one of the key things to take into consideration in the MS method is the cycle time. Especially working with, like you have seen in this application of 100 samples per day, most of the peaks are eluting over like 2 or 3 seconds. And if your cycle time is 2 seconds, that means like, 1 or 2 points per peak, which will lead to the very poor quantification. So this is a feature that really has to be taken into account.
Exactly. All right. So again, if you have questions, please put them into the chat box, and we will answer the questions. So another thing that I think would be interesting in this topic to discuss, Djordje, is installation, or expectations to. I mean, what happens when you buy an instrument, right? So what happens during installation? How long time does it take before you start to run your samples? What about familiarization? Kind of, if it is a new technology that you want to bring into the lab. So what happens after you receive the box, big wooden box with your bright orange Evosep inside?
So I have to say I haven't done installation in a while, but I don't know how the process works. So once the box arrives, we schedule the installation visit from our service engineer. And first day of the installation, the service engineer would take the instrument out of the box, assemble it, calibrate it, and then also prepare a set of, do all of the diagnostics, obviously, and fill in the diagnostics report, and then prepare the set of PSA samples that we also use internally in factory to validate the performance of our system on the MS, and let them run overnight. Next morning, the engineer will come back, validate those MS data, and then proceed with the user training. And this is a comprehensive training that will explain how the system is operating, that will teach you how to load the tips. And in this case, this will almost always be manual tip loading, because this is the base of the proper tip loading. And then also explain to you and teach you how to use the software and how to run different methods, and have a little bit discussion about that. If there is in most of the cases, customer already have samples kind of ready digested and would like to try them together with the engineer. This is something that we usually accommodate, and then we can add a few more samples that will run on the system. And in most of the cases, customers simply just start running the samples right away. In some cases, there are customers would like to have some additional training that is specific for their application. And we also do offer what we call advanced application training that would, in Europe at least, usually be done by me, where I would visit the lab, and then we can go into the little details of the specific applications that you are interested in the lab, where I would help you set up your experiments and optimize it, how to best run it on the Evosep system. So that is the expectations, and this is what happens all of the time.
Great. A question along those lines is a practical question. So where to start? Let's say I have a Healer digest of 500 nanogram. What are the solvents I need to prepare? How do I introduce the sample into the Evotip? And what are the methods, or what method should I use, and how to operate the software? So maybe you want to start on that one, Iulia.
Yeah. So I think Djordje covered this very well. It's funny because he's actually the one who trained me on the Evosep 1 back in the day. So I think he did a very good job, because here I am. No, but it's very easy. It's a straightforward procedure. You would have your solvent A, solvent B, and then IPA, and then you would just typically use a lysate of HeLa that you would prepare, so loading on the Evo tips, and it's always the same protocol. So this also kind of links to what we talked about earlier. It's the fact that we always perform the same procedure makes the system and the entire workflow reduce this variability. So you would always once you acquire the data and you start to look at it, you can establish a baseline, kind of a QC of your system, depending, of course, on the MS that is behind the Evosep. But you would always expect this data to look the same, and this is how you kind of set up your benchmark and kind of get going from there. But all the steps should be very easy, very plug and play to get going.
Anything to add, Djordje?
I would also add that one of the things that comes in the box when you buy the instrument is a tip loading kit. So there is like all of the plasticware adapters and everything that is needed for you to successfully load, apart from the centrifuge, obviously. Everything that is needed for the manual tip loading will be in the box, and then the other things that you need is just the MS grade solvents. So those are solvents A and B, the same ones that you use for the instrument, so water and acetonitrile with 0.1 formic acid, and propanol or isopropanol for the tip conditioning. And this is pretty much everything. And then everything else is the standard lab stuff. You have the pipettes in your lab. Not ideally, we definitely strongly suggest using really high quality, low bind plasticware for everything, so you don't lose your peptides. But you are essentially ready to load any kind of sample that you have digested right away after the installation.
Yeah, exactly. And again, another question that falls within this space is, what would be the maximum load capacity for the Evo tip? We should not exceed what threshold? Djordje? Sorry.
Okay, me. Well, the question is not just regarding the Evosep, but it is also very much dependent on which mass spec you want to run on. But what we have tested and seen is that the binding capacity of Evo tip is around 1 microgram. So if you are loading much more than 1 microgram, it is just going to wash through, so it is not going to stay on the tip. And Evosep columns will be perfectly capable of handling 1 microgram, but the problem is if you're running it on, I don't know, like timsTOF Ultra, this is going to be way too much and you're going to oversaturate your mass spec. This is also not something that you should do with the whisper methods and ion optics columns, because this is going to heavily overload that setup. So the answer definitely depends on the mass spec and on the application, or actually LC method that you're planning to run. But 1 microgram is the upper limit of what can be done. And the lower limit does not exist.
Yeah. So we have done a lot of experimentation showing that we get linearity when loading up to at least 1 microgram. So as Djordje says, you don't want to saturate your MS. So you should be careful if you go higher. In some cases, you can also go higher. We just haven't tested for that, because you should also be mindful of matrix effects that could affect your binding capacity. So 1 microgram is a safe limit. You may be able to go higher if you have the need, but be mindful about not loading too much. You'll kill your mass spec. So there's a question. I'm not entirely sure. It's basically asking, is there a basic tutorial for that? Well, I mean, we have tutorials. We also have a loading, how to load your Evo tips tutorial. If that's what you're referring to, then yes. We also have other tutorials, as Djordje mentioned during his presentation. If not, then please feel free to re-ask that question.
And if I can add, Nicolai, there is also the very comprehensive user guide that will also explain to you how to install the software, how to run the software, how to open, how to create the sample queue for all of the different mass spec vendor options. So we do show you how to integrate in, I don't know, SciXOS, HiStar, Excalibur, and all of the other things. So there is quite a lot of material on how to set up everything, and quite a lot of that in video library as well.
Yeah. So everything can be found on our webpage. So yeah, that's a really good repository to go and look into. So another question, very relevant question, I think. What is the difference between the Evosep 1 and the Evosep Eno that has helped improve the chromatography? So maybe you want to start on that one, Djordje.
Yes. So one of the there are two differences between Evosep 1 and Evosep Eno. There is a slight difference in fluidics for the standard methods and essentially in the flow part of the peptides. The strategy of creating the gradient and storing it in the loop is slightly different, but the major improvement between 1 and Eno is the complete electronics, so the control of the pumps, the control of the communication between pumps and flow sensors. Everything is completely overhauled and improved, which means that the gradient formation is much tighter, which reflects in the much more stable retention time and sharper peaks. And then we have also now switched to just using the performance columns with the smaller beads that produce higher sharper peaks and higher peak capacity. So all of those factors combined lead to the performance increase that we see across all of the methods.
Yeah, exactly. So a good question for you, Iulia, is how can we keep the Evosep columns after use? Is it possible to elute with higher organic solvent? So I guess the first bit, I mean, how to keep the columns after use?
I don't think you have to do anything in particular. Once you finished using your column, it's pretty much we just keep them. And these columns are, as Djordje said, the performance columns that we use on the Evosep Eno, and they are designed to last a very long time, so to accommodate a lot of injections. And I don't remember the number of injections that columns can actually see before we kind of decide to, but I guess you would see, right? Yeah, and then you would see it on your peaks that they start to deteriorate in that way. So yeah.
Yeah, I guess it's a little bit of a trick question, yeah. Right? Because essentially we don't do anything. I mean, we just take the column off and store it on the bench or in the drawer when not using it. And one of the reasons I think this is doable is that every time we end a method, it always ends in high organic. So despite eluting from the Evosep at maximum 50%, sometimes lower, we still wash and clean the column at much higher organic. And that's the last thing that sits in the column, unless you do idle flow, which I typically do not recommend. Djordje may and Iulia may have a different opinion. It's a religion, I think. But essentially, we have not seen any issues whatsoever with just taking off the column, leaving it in the drawer or on the bench, and then when we put it back on, we basically just need to just do one run to equilibrate and get the column back in shape. Yes. And then you would. Any comments from you, Djordje?
I would. My only comment would be for our column. I always suggest to customers to when you store it for a longer time, put it back in the original box, because then it can be closed and protected from dust. Because if there is, some labs are clean, but some labs are very dusty, and if there is a dust particle sitting on the connector, then you squeeze it into a meter, and then it can create problems. But apart from that, they are absolutely fine sitting dry in the box in the drawer for a long time. And as you said, afterwards, just run 1 or 2 HeLa samples to equilibrate it, and it's good to go again.
Yeah. So a question that fits really nicely into this topic. After a sequence, it just popped in. After a sequence is finished, what happens to the flow? Does it stop? Question mark. And what about the source voltage? Is it switched off? So Djordje, maybe you want to comment on this one.
What happens after the sample is done depends on how the system is installed. So when we do the installation, we always ask customers, do they want the automatic idle flow or not? So, and this also depends a little bit, as you said, it's for some people it's religion, but it's also sometimes the recommendation of the mass spec vendor. It also depends on if you want to, which column you want to run. For example, if the system is sitting with, if you're going to primarily use whisper zoom methods and have ion optics column, ion optics also says that those columns like to have continuous flow, then the idle flow option, automatic idle flow option would be chosen, which means that no matter what you are doing with the system, whether it is like the samples running or you run any diagnostics or preparations, if the system is sitting idle for more than 2 minutes, it automatically kicks in idle flow at 250 nanometers per minute. If that option is not checked during the installation, and this is something one can change in configuration later on, then the system just stays idle and waits for the next command. Maybe nice thing to say here is that if the system is idle for a while, obviously there is like the air is going to accumulate inside of the system, and then the solvents are not going to be perfectly aligned on the point of contact. The system is built in a way that it prevents that, it knows that. So if the system was sitting idle for some hours, before, when you start your sample queue, before even if it starts the sample, it is not going to ask anything, it's just going to kick in automatic round of degas to make sure that the system is in top condition for the first sample in the queue. And then the degas will be part of the sample happening in the background while the sample is running with a high pressure pump. But yeah, I hope I answered the question.
Yes. For the MS part, it highly depends on the MS with the voltage. I guess most mass specs have that preset, or you can configure it to stop at the end of a batch to not apply voltage while there's no flow.
Yeah, exactly. Yeah. So I guess I mean it really depends on the column, as Djordje says. I think my opinion is that for all our standard methods where we have a pretty robust and rugged setup, steel emitters and so forth, I would not use idle flow. I would just let the sequence run out. The Evosep will stop. It will slowly depressurize through the column, ensuring that the column is cleaned very well. And then ensure that the mass spec also goes into idle. For the whisper methods where we use ion optic columns, which is a pooled column, pooled emitter, right? They are a little bit more sensitive, and I think that this is probably where idle flow, in my view, becomes important, handy, because we do use the columns at higher temperature, 50 degrees. And also they have a tendency to block the emitter tip if they don't see a continuous flow. So this is where I would use the idle flow option. So yeah. So another question. This time I'll start with you, Iulia. So what is the typical lower limit of detection for peptides, proteins, and which possibilities do I have to optimize sensitivity?
I think if we're talking more about quantitative approach, so if we decide to go more targeted, we have seen sensitivity down to low attomole levels, and that actually allows us to have a very wide dynamic range of more than 5 orders of magnitude. So obviously when you go low flow, you can also push for that very low, very high sensitivity to get the best out of your system. And the Evosep is excellent at providing that baseline where we can push for very low limits of detection and quantification.
Yeah, I think before I also let you comment in a sec, Djordje. So I think it's important to remember that sensitivity covers many areas, right? So basically, sensitivity is affected by how much you can capture and recover. I mean, basically, if you lose a lot of sample for your analysis, that's going to affect your sensitivity. Then you have the separation device, in this case the Evosep system. If you're able to get really good chromatography, very sharp peak, that is going to increase the likelihood that your detector, the mass spec, is able to detect those ions. But ultimately, it's really the detector that is detecting, right? So you can have losses throughout kind of the different components of the workflow, but at the end of the day, it's the detector that defines the sensitivity and how you use the detector. Because if you sit on some of these, you know, if as Iulia mentions, if you have a tighter workflow and you accumulate ions, then you will increase your sensitivity. If you have better chromatography, that's going to improve your sensitivity. But that doesn't mean that you don't have to really consider the workflow and also how you capture that sample, right? So you don't have the losses, because they will also affect your sensitivity. And this is where, back to our different collaterals, we have a lot of very nice collaterals in high sensitivity space, you know, single cell space, deep visual proteomics, where the benefits of the Evotip as basically the device that is super efficient in capturing your sample, and also integrating the Evotip very early into the workflow is what really kind of helps boost the sensitivity, because we don't lose sample. And then of course, is at the end of the day is how well do we then use the detector, and how sensitive is the detector, the mass spec, at detecting what we managed to introduce into the mass spec. Any comments, Djordje, on that?
No, you pretty much covered what I wanted to say. This is mostly coming to the sample losses before they are even on the tip. And we do have a lot of material on the website on that. There are also our customers develop different approaches, like in-tip digestion, like one tip approach from Jesper Olsen lab, or like the applications with the CellN1. But obviously, this is always dependent on the specific project, and I would just say from my side, this is also something that I have been engaging with customers on many occasions. If you have any specific questions that are also like specifically related to your protocol, please, don't hesitate, write to support, and then we can take it from there.
Yeah, really good comment, and I think that was kind of my wrap up. Sentence. So Djordje is absolutely right. So we have time for one more question. We're almost at the top of the hour. But as Djordje says, I mean, there's a lot more questions that we won't be able to cover today, unfortunately. But if you have questions, you know, feel free to reach out to any of our colleagues, Djordje, and also our American-based product and sales specialists. More than happy to engage in a dialogue and help you out in you know, whatever questions you may have, if you need to optimize, or if you need information about, you know, how best to use the Evosep technology. So definitely a good comment, Djordje. Last question. You kind of covered it during your talk, Djordje, but the question is basically around the source heating required for all methods, or basically, is MS source heating required for all methods on the Evosep? Yes. Eno? So is it Evosep or OEM parts that we need for this? And yeah, maybe you want to elaborate, Djordje, on that topic.
Yes, so heating is required for all of our columns and for all of our optics columns. In case of Bruker or SAIX mass spec instruments, SAIX with the OptiFlow, so they come with a built-in column heater that suits our columns perfectly. Ion optics column, they have their own solution for the heating, so we do not have to cater to that specifically. And this is, you know, on Ion optics website, if it is available, if there is available heating for the mass spec, then you can probably use them. And then from our side, for Bruker instruments, Bruker Toaster, that is mostly coming with all of the Timstor series instruments and other, I believe, as well. Again, fit our columns. And then we have developed Evosep for all of the other sources that are commonly used in combination with Evosep instruments, but didn't have the elegant solution for heating, like for thermo, both easy and flex source. It was always a little bit difficult and clunky at best. And then also for Waters and Agilent that came recently, we didn't have a good solution until Evosep came out. That does cover, to the best of my knowledge, almost everything that is used in combination with Evosep now. But if there are other specific requirements needed, get in touch with us again, and then we can see how can we best help you.
Exactly. Yeah. So I mean, to Djordje's point, so basically all methods on the Evosep Eno requires heating. So standard methods are optimized for 40 degrees. Ion optics are 50, or the whisper with ion optic columns are intended for 50 degrees. Ion optic comes with heating in their technology, so that's not a problem. Broker has their own, but for the thermos, the mass specs that does not have a nice solution, that's where we've developed the pod, just to mitigate that gap. But if there are, I mean, it doesn't necessarily need to be the pod. It's just a very nice and elegant product. It's a very simple device that allows you to do what was required for the technology.